LCM and HCF by prime factorization method. Let us see example number 1. Find the LCM and HCF of 36 and 60 by prime factorization. First of all, given numbers resolve into prime factors. 36 resolve into prime factors. 2 18s are, 2 9s are, 3 3s are, 3 1s are. Now we express as 2 into 2 into 3 into 3. Similarly, 60 also resolve into prime factors. 2 30s are, 2 15s are, 3 5s are, 5 1s are. Now we express as 2 into 2 into 3 into 5. And 36 we express as exponential form. Here in the prime factorization, 2's are 2, 3's are 2. That's why 2 square into 3 square. 60 we can express as exponential form. 2's are 2, 3 is 1, 5 also 1. That's why 2 square into 3 to the power of 1 into 5 to the power of 1. Now here prime factors we have only 2, 3, 5. What is the LCM? LCM is equal to product of greatest power of each prime factors. Product of greatest power of each prime factors. Now we have only 3 prime factors, 2, 3, 5. As prime factor 2, which is the greatest power? Both are equal. So it's also take as smallest or greatest. Now here 2 square. Now go to 3. 3 as a factor. So here greatest power is here. Now observe 3 in 36 3 square, in 60 3 to the power of 1. Now which is the greatest power? 3 square. So here 3 square. Now next go to 5 as a factor 5. So here only 5, greatest power is 5. So that's why into 5 to the power of 1. Now 2 square is a 4 and 3 square is a 9 and 5 to the power of 1 is a 5. So 4 into 9 into 5 we get 180. Now HCF, product of smallest power of common prime factors. Common prime factors. Here we have prime factors 2, 3, 5. So which prime number is a common factor for both 2 and 3? Now observe 2 and 3. Here in 36 2 square, in 60 2 square. Here is a 2 is a prime factor. Here also in second number also 2 prime factor. And 36 3 and 3 square. Here 60 also 3 to the power of 1. So here product of smallest power of common prime factor. Only 2 and 3 are common prime factors, not 5. So here smallest power, but 2 square is in the prime factorization of 36 and 2 square also in the prime factorization of 60. Both are same. So both are same. We take as a smallest and greatest also. Here now smallest, that is a 2 square. Now go to factor as a 3. Now here in 36 3 square, in 60 3 to the power of 1. Which is smallest? 3 to the power of 1. 1. 1 is the smallest power. So that's why it's a common and smallest. Now 3 to the power of 1. Now 2 square is 4 and 3 to the power of 1 is 3. Now 12. So therefore LCM of 36 and 60 is a 180. HCF of 36 and 60 is a 12. And next we go to second example. Find the LCM and HCF of 35 and 12 by prime factorization method. Now here 36 resolve into prime factors 3. So 5 7s are 7 1s are. Now 35 is equals to 5 into 7 is equals to 5 to the power of 1 into 7 to the power of 1. And 12 is equals to 12 resolve into prime factors 2 6 are, the 2 3s are 3 1s are. Here 12 expressed as product of primes 2 into 3. We express as also 2s are 2 and 3 is 1. So that's why we write exponential form 2 square into 3 to the power of 1. Now here prime factors 2, 3, 5, 7. 2, 3, 2, 3, 5, 7. So that's why now LCM of 35 and 12 is, first of all, write the formula. Product of the greatest power of each prime factors. Now as a factor 2, which is a highest power in as a 2 factor, now only 2 is only 1, that is the greatest. So that's why 2 square. 3 also only 1 factor, so that's why 3 to the power of 1. And 5 also 1, 5 to the power of 1. 7 also 1, 7 to the power of 1. Now 2 square is a 4, 3 to the power of 1 is a 3, 5 to the power of 1 is a 5, 7 to the power of 1 is a 7. So that's why 4 into 3 into 5 into 7 we get a 420. And HCF of 35 and 12. Now product of smallest power of common prime factors. Now observe in the prime factorization of two numbers. In 36 only prime numbers 5 and 7. In 12 2 and 3. No common prime factors here. No common prime factors. So here, so how to get the HCF? What is the HCF for both? So that's why any number we can write as into 1. So 1 also factor of every number. So that's why into 1 and 12 also into 1. So now 1 is a common factor for 35 and 12. So therefore LCM of 35 and 12 is a 420 and HCF of 35 and 12 is equals to 1. Now go to third example. Here is a special case. It is a high level standard example. A, B, C are prime factors and 3 numbers expressed as A square into B to the power of 1 into C square. And second is A to the power of 1 into B square. And the third one a square into b cube into c square. Then find the LCM and HCF of them. Now given first number is a square into b to the power of 1 into c square. Second number a to the power of 1 into b square. Third number a square into b cube into c square. So here prime factors. What are the prime factors here? A, B, C are prime factors. So now LCM. LCM is equal to product of greatest power of each prime factors. So here as a factor A, so which power is the highest here? Which power is highest here? In first number a square, in second number a to the power of 1, in third number a square. So highest power is 2. So that's why here a square. And we go to next prime factor as b. So here which power is the highest among three numbers? Here in first number b to the power of 1, in second number b square, in third number b cube. So that's why we take greatest power is 3 as 3. So that's why here b cube. And next go to prime factor as c. So in first number observe, in first number c square, second number does not have, and next third number c square. So here greatest power is c square. So that's why c square. Now a square, b cube, c square. This is a LCM. Next we go to HCF. HCF is the product of smallest power of common prime factors. Common prime factors. So here now here a is the common prime factor for three numbers, and also here we observe here first number a square, second number a to the power of 1, third number is a square. Here we take as smallest power, which is the smallest. A to the power of 1 is the smallest. 1 is the smallest power. That's why a to the power of 1. Next we go to second. Second factor is b. So in first number b to the power of 1, in second number b square, in third number b cube. B is the common factor for three numbers. That's why smallest power is a 1. That's why we take as b to the power of 1. Next we go to factor as c. So here in first number c square, in second number it does not have a c factor, and in third number c square. So c is a common factor for only two numbers, not three numbers. So we does not take a common factor as c. So that's why the HCF only a to the power of 1 into b to the power of 1. So now finally we get a b. So now LCM is equals to a square, b cube, c square. HCF is equals to AB. Thank you for watching.